anything you want from anything you want, really, anything. So we have from 9 through 54. You choose. We're going to practice this before we look at definite integrals. Slightly different situation there.
Let's look at 18.
18, very good. So for 18, let me start. I did start a new video. Okay. So the integral from z squared over z to the third plus 1 dz. Okay. I'm looking at this function, and I say, like before, I say this to myself. This piece, nice. This piece, not. How come? Why isn't this nice? To me, it's not nice because 1 over a plus b cannot be simplified. I can't do anything to it. But if somehow I present it as 1 over c, this I can handle, because this is c to negative 1, so who knows what opportunities this will give. But this I don't like. 2 terms in the denominator, I'm stuck. So that's my starting point. I'm going to say,
substitute
yes.
Denominator.
Yes. So give me any letter you want to use. Any letter. It doesn't matter.
We can use u.
Okay, very good. So then z to the third plus 1. As long as I can make up the du, because I know it's ridiculous, but I just want to make up a point. If du equals tangent x dx, how can I make a tangent x from this? I can't. If a number is missing or, something close, I can. But if the du is tangent x, how do I do the tangent x in that? So can anyone give us the du for this function?
That's 3z squared times dz.
Awesome. So let's see what pieces we have and what pieces we don't. What I don't have is a little 3. Who cares? Little 3 can be made up any moment, day and night. What do I replace this piece by?
You can replace it du.
That's it. This whole thing is du. What do I replace this piece by? Because everything has to be replaced. I cannot, please do not write an integral with z and u and dz. No, no, no. Be very careful. Only one variable per integral. So what do I replace this piece by? With 1/3 in front.
Do you say u?
That's it. That's how we started. So this is the integral from du over u. Can be easier than that. Good. So this is 1/3. Which function prime is 1 over u?
Natural log u.
Excellent. Plus a constant c. Don't forget the absolute value. Now I have no choice. I have to go back and put my function back in. Done. That's it. Well done. See what we can do together. Back to other examples. Before that, let me stop for a second and ask you if you have questions. That is it. That's the substitution rule. Choose anything else. This caught my eye, but it's up to you. This caught my eye, but it's up to you.
Yeah, 28.
28 it is. Good pick. 28. The integral from x, the square root of x plus 2 dx. So these substitutions not only teach us the rule and how to integrate, but also how to look at functions. So look at this function and tell me what you like and what you don't like about this function. You know it's not a scientific way. I'm just teaching you the simplest possible way to look at the function.
Like the x, don't like the square root.
Say it again.
Like the x, do not like the square root of x plus 2.
Yes, because the square root of a plus b cannot be simplified. You can never write this. So you're stuck with this. Completely stuck. So, because it cannot be simplified in any way with minus as well. So, what if we say, let u be x plus 2? Is du in the problem? How much is du?
One.
Not 1. One more time. Careful, this is extremely super important. Du is not f prime, but f prime dx.
So just the x.
That's it. Awesome. Great job. So then this is du. This again, what is it?
U to the negative 1.
Oh, no. It's the positive 1/2, right? It's the square root. Good. So now we are encountering some sort of situation, slightly, a little situation. This is accounted for. This is accounted for. But I have this little piece in front. Is there any way I can present this piece in terms of u? Because I cannot have x and u in the same integral. That would be a terrible mistake. Is there any way to present this piece in terms of u?
X equals u minus 2.
That's it. Brilliant. That's it. So then, here it is. The integral from u minus 2 times u to 1/2 times du. And you can say, you accomplished nothing. I accomplished a lot. Because now I can distribute and break this up into 2 pieces, which I couldn't do over there. That was done. That was stuck. I was stuck there with that square root of a sum. But here, I have one term to 1/2. I'll distribute here, add the exponents. So this is now u to 1 plus 1/2, so 3/2 minus 2u to 1/2 du. This is piece of cake. That difficult. How do I do that? I have no idea. Here, easy. So u to 3/2 plus 1 over 3/2 plus 1 minus 2 u to 1/2 plus 1 3/2 over 3/2 plus a constant c. Flip, flip, and replace. 2/5 u. What was u? X plus 2 to 5/2 minus flip 4/3 x plus 2 to 3/2 plus a constant c. Done. So always look at the function, decompose it with your eyes, and say, that's my starting point. In more than one situations, more than one substitution will work. Do you have to choose a particular one? No. If one works, I'm happy, you're happy, you got the integral done. Who cares? And yes, 2 people can come up with different functions whose derivative is that function. So it is possible that there is more than one unique answer. Good. Next. You choose anything. Okay, my time to
Because I
choose.
need work
Yep,
with
go
you.
ahead, go ahead, sorry.
34, because it's secant and tangents, and just I need work with this.
Of course, very good. Let's take a look at 34. 34 it is. Thank you for choosing, by the way. You make my life easier. Yeah, I love when my students contribute and ask questions and etc. etc. Okay, so good. I have no idea what this is, but I have to think in terms of choosing, like we discussed before, choosing u in such a way that du is right there in front of us, plus or minus a constant that I can always handle very easily. So what are the options? You can say use u to be secant, but then I'm in trouble because secant prime is secant tangent. What do I do with that? How do I get du? But if I use tangent,
Secant squared.
yes, secant squared dx. So what is this then?
Du.
That's it. What is this then?
U squared.
That's it. So the integral is the 1 over u squared du. And a long time ago, I begged you to remember that negative 1 over u prime is 1 over u squared. Okay? Plus a constant c. So remember we had 1 over u prime, and I said this is negative 1 over u squared, or 1 over u squared is negative 1 over u prime. A long time ago when we discussed the differentiation. This is a good habit. This is a good, because otherwise you have to put u to negative 2 plus 1 over negative 1. It's fine. It's not a mistake, but it will take you longer. It's done, but I have, because it's an indefinite integral, I have to go back and substitute. So this is negative 1 over tangent x plus a constant c. Now you can say stop and show me that this is correct. Yes, I can, by checking. If you want, and say check. Okay, I will differentiate this. Negative 1 over tangent x plus a constant c. First of all, I'm going to write it like this. Not to be understood that this is, maybe I should not write it like this. I should write it like this. So I don't want you to think that this is the inverse function. Please make sure you understand that this is not arctangent. That's why I mostly write arctangent and not tangent inverse, not to be confused with 1 over. So when I differentiate this, I bring negative 1 in front, so I have 1. Tangent to negative 2, and c prime is 0, times the inner function prime. So I bring negative 1, multiply by negative 1, so it's 1, subtract 1 from the power, times the inner function prime, which is secant squared x, which changes into secant squared over tangent squared. So I got back my function. So I checked. By differentiating this, I got the original function back, secant squared over tangent squared. Bring down negative 1, subtract 1 from the power, differentiate the inner function, secant squared over tangent squared, because this is power negative 2. Excellent pick, thank you. Oh, I'm sorry, I didn't mean to take it that fast. Sorry. Can we move on to the definite? Or do we have something else to look at?
Can you do 44?
44 it is. Good pick. Let's look at 44. I think I'm on page 9. Sometimes I write the same page 3 or 4 times. It happens. Okay, 44. And we have the integral from dt over cosine squared t, the square root of 1 plus tangent t. Yep. Okay. Good. Which piece you would like to start with? What do you think is more complicated? Because you cannot denote cosine and the inside of the square root at the same time, right? It's not possible. So we have to focus on one or the other. Hold on just 1 second. Let me